Preparing for a production engineering interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you investigate a sudden increase in application latency? I start by confirming whether latency affects all requests or a specific path, region, or customer segment. Then I compare dashboards with historical baselines, inspect percentiles rather than averages, and use distributed traces to locate the slow component. I check deployments, dependency health, database saturation, queues, and infrastructure changes. If impact is severe, I mitigate first by rollback, traffic shifting, or capacity expansion. Afterward, I identify root cause and document preventive actions. While answering, focus on establishing the timeline, measuring affected endpoints, comparing baselines, checking recent changes, analyzing metrics and traces, isolating dependencies, and communicating mitigation alongside root cause investigation. Question 2. What metrics would you monitor for a production service? I monitor latency, traffic, errors, and saturation as the core service signals. Latency should include P50, P95, and P99 because averages hide tail problems. I also track request volume, error types, queue depth, CPU, memory, database health, dependency failures, and business metrics such as successful checkouts. Dashboards should show trends and useful breakdowns by endpoint, region, and version. Alerts should indicate actionable customer impact, not every minor fluctuation. Make sure to cover the 4 golden signals: business indicators, saturation, dependency health, percentile latency, error classification, capacity trends, dashboard usability, and alert thresholds that reflect customer impact. Question 3. How do you design effective alerts without creating alert fatigue? Effective alerts tell an engineer that customers are being harmed and that action is required. I anchor thresholds to service-level objectives, using error budget burn rates when possible instead of arbitrary CPU limits. Each alert needs an owner, severity, runbook, and escalation path. I group related symptoms, suppress duplicates during known incidents, and review alert history regularly. If an alert is repeatedly ignored or produces no useful action, I tune or remove it. In your answer, discuss symptom-based alerting, service-level objectives, severity levels, actionable thresholds, burn rate alerts, deduplication, ownership, escalation paths, and regular review of noisy notifications. Question 4. What is an SLO, and how would you use it in production operations? An SLO is a target for a measurable service-level indicator, such as 99.9% successful requests or a P99 latency limit. I use it to define reliability in customer terms and calculate the remaining error budget. When the budget is healthy, teams can ship faster. When it is exhausted, reliability work takes priority. SLAs are external commitments with consequences, while SLOs guide engineering decisions internally. Good SLOs are realistic, measurable, and reviewed periodically. Be sure to mention SLIs, slow targets, SLAs, error budgets, customer experience, release decisions, alerting, and the balance between reliability investment and feature delivery. Question 5. Walk me through your approach to handling a production incident. I first acknowledge the incident, assess customer impact, and establish an incident commander. I assign separate owners for mitigation, investigation, communications, and documentation so work does not collide. I prefer reversible actions such as rollback, disabling a feature, or shifting traffic while preserving evidence. I provide regular stakeholder updates using known facts and next steps. After recovery, I verify key metrics, conduct a blameless postmortem, and track preventive actions to completion. Focus on incident command, impact assessment, roles, mitigation, communication, evidence preservation, decision logging, recovery validation, and a blameless postmortem with concrete follow-up actions. Question 6. How would you safely deploy a high-risk change to production? I reduce risk before deployment through review, automated tests, dependency checks, and a documented rollback plan. For a high-risk change, I use a feature flag or dark launch, deploy to a small canary population, and compare error rates, latency, and business metrics against control traffic. I define stop conditions in advance and expand gradually. Database changes must remain backward compatible across versions. If signals degrade, I halt or roll back immediately. Mention automated testing, peer review, small changes, feature flags, canary releases, progressive rollout, observability, rollback criteria, database compatibility, and explicit approval for high-risk operations. Question 7. What is the difference between a rollback and a roll forward? A rollback restores a previous application version, while a roll forward deploys a new change that corrects the defect. I prefer rollback when the previous version is known to work and dependencies remain compatible. Roll forward makes sense when rollback could lose data, break a schema migration, or reproduce the problem. Both require validation and monitoring. I design deployments so application versions tolerate temporary schema differences, keeping rollback practical during incidents. In your answer, compare reverting to a known version with fixing forward, discuss database and schema constraints, recovery speed, validation, risk, and when each approach is safer. Question 8. How would you troubleshoot a memory leak in a production service? I first confirm a leak by checking whether memory grows over comparable traffic and fails to return after garbage collection. I correlate resident memory, heap usage, allocation rates, restarts, and request patterns. Then I capture safe heap or allocation profiles and compare snapshots to identify retained objects, caches, listeners, or unclosed resources. I may reduce traffic, restart instances gradually, or increase capacity as temporary mitigation. Finally, I reproduce the pattern, fix it, and verify stable memory over time. Cover symptoms, heap and resident memory metrics, garbage collection, allocation profiling, leak reproduction, traffic correlation, safe diagnostics, mitigation, and verification after deploying the fix. Question 9. How do you debug a service that is consuming excessive CPU? I verify that CPU saturation is real and determine whether it is caused by higher traffic, a new version, or a specific request type. I inspect per instance and per endpoint metrics, then use low overhead profiling to find hot functions, lock contention, serialization costs, or excessive garbage collection. As mitigation, I can scale out, rate limit expensive operations, disable a feature, or roll back. The durable fix should be validated under representative load before full rollout. Discuss confirming saturation, identifying affected versions and endpoints, profiling safely, checking traffic changes, lock contention, inefficient algorithms, garbage collection, dependency behavior, and short-term mitigation. Question 10. How would you diagnose intermittent network failures between services? I separate connection failures, DNS errors, timeouts, resets, and application-level errors because they point to different layers. I compare affected hosts, zones, regions, and timestamps, then inspect DNS resolution, load balancer logs, route changes, connection pools, packet loss, and dependency saturation. Traces show where requests stop. I avoid blindly increasing retries, since that can amplify load. I use bounded timeouts, controlled retry budgets, and traffic shifting while isolating the network fault. Be sure to cover failure frequency, timeouts versus connection errors, DNS, routing, load balancers, retries, packet loss, dependency health, regional patterns, and evidence from logs, metrics, and traces. Question 11. What makes a good production runbook? A useful runbook lets an on-call engineer act under pressure without relying on tribal knowledge. I include symptoms, likely causes, dashboards, logs, commands, access requirements, decision points, mitigation steps, rollback instructions, and escalation contacts. Every action should state its risk and expected result. I also define recovery checks, such as restored error rates and queue depth. Runbooks need testing during drills and updates after incidents, otherwise they become misleading documentation. Mention clear symptoms, scope checks, prerequisite access, diagnostic commands, decision points, safe mitigation steps, rollback instructions, escalation contacts, validation criteria, and regular ownership reviews. Question 12. How would you improve the reliability of a service with frequent outages? I would first quantify outages by frequency, duration, affected users, and root cause category rather than treating every event separately. I would establish meaningful SLOs, map dependencies, and identify the largest contributors, such as unsafe releases, capacity limits, or weak failure handling. Then I would prioritize reversible deployments, better alerts, load testing, redundancy, and automated recovery based on customer impact. Progress should be measured through reduced error budget consumption and fewer repeat incidents. Focus on outage classification, slow measurement, recurring root causes, dependency mapping, capacity, testing, automation, safe deployments, observability, ownership, and prioritizing improvements by customer impact. Question 13. Explain how you would capacity plan a production service. I begin with historical traffic, growth projections, workload characteristics, and business events such as launches or seasonal peaks. Load tests establish how throughput affects latency and resource saturation, including bottlenecks in databases and external dependencies. I provision headroom for normal variation and failure scenarios, then verify autoscaling behavior and maximum limits. Capacity planning is continuous. I compare forecasts with actual usage, monitor cost, and revisit assumptions whenever architecture or traffic patterns change. Discuss demand forecasting, resource saturation, load testing, headroom, seasonal peaks, scaling limits, dependency capacity, cost, failure scenarios, and continuous validation against real production behavior. Question 14. How do retries, timeouts, and circuit breakers work together? Timeouts prevent a request from waiting indefinitely, while retries recover from transient failures. I use exponential backoff with jitter and strict retry limits to avoid synchronized retry storms. Retried operations must be idempotent or protected with request identifiers. A circuit breaker stops sending traffic to a failing dependency, allowing recovery and protecting callers. I apply these controls together with monitoring and budgets. Aggressive retries can turn a small dependency outage into a widespread incident. In your answer, explain bounded timeouts, exponential backoff, jitter, retry budgets, idempotency, circuit states, cascading failures, and choosing policies based on dependency behavior. Question 15. What are the operational risks of a distributed system, and how do you manage them? Distributed systems fail partially. One dependency, zone, or network path can break while others remain healthy. I manage that uncertainty with timeouts, bounded retries, idempotent operations, health checks, redundancy, and clear degradation behavior. I avoid relying on perfectly synchronized clocks and make consistency requirements explicit. Strong tracing and correlation identifiers help reconstruct behavior across services. The design should distinguish critical operations from optional features, preserving core functionality when dependencies become unavailable. Cover partial failure, latency, inconsistent state, clock assumptions, retries, coordination, observability, graceful degradation, redundancy, idempotency, and explicit consistency trade-offs. Question 16. How would you respond to a database performance degradation in production? I determine whether the issue is slow queries, lock contention, connection exhaustion, storage pressure, replication lag, or an upstream traffic change. I inspect database metrics and query plans, comparing affected queries with recent deployments and data growth. Immediate mitigation might include throttling traffic, disabling an expensive feature, adding read capacity, or reverting a query change. I avoid unreviewed indexes or parameter changes in the incident. Afterward, I optimize, load test, and monitor the result. Mention query latency, execution plans, locks, connection pools, indexes, storage and CPU saturation, replication lag, recent changes, safe mitigation, and avoiding harmful emergency fixes. Question 17. How do you secure production systems while maintaining operational access? I apply least privilege through role-based access, short-lived credentials, service identities, and separate production permissions from development access. Secrets belong in a managed vault, never in source code or logs, and should be rotated automatically. Administrative actions need audit trails and, for sensitive changes, approval or dual control. I maintain a tested break glass process for emergencies, with time-limited access and review afterward. Security controls must be observable so unusual access is detected quickly. Be sure to discuss least privilege, role-based access, short-lived credentials, secret management, audit logs, break glass procedures, network controls, patching, and separation of duties. Question 18. What is observability, and how is it different from monitoring? Monitoring tells me whether known conditions are healthy through predefined metrics and alerts. Observability gives me enough internal signal to understand novel failures, using metrics, structured logs, and distributed traces. For example, a latency alert identifies a symptom, while trace attributes can reveal that one tenant, endpoint, or dependency causes it. I instrument meaningful boundaries, preserve correlation identifiers, and control cardinality and cost. Good observability shortens diagnosis without collecting unnecessary data. Explain metrics, logs, traces, high cardinality dimensions, unknown failure modes, instrumentation, correlation, and how observability supports debugging beyond predefined health checks. Question 19. How would you automate a repetitive operational task safely? I first document the manual steps, inputs, failure modes, and desired outcome. I make the automation idempotent, add validation and dry run support, restrict permissions, and require explicit confirmation for destructive actions. Every execution should produce structured logs, metrics, and an auditable result. I test against realistic environments, roll it out gradually, and retain a manual fallback. Success means less toil and fewer mistakes, not merely replacing keystrokes with a script. Discuss defining the manual workflow, validating assumptions, idempotency, dry runs, permissions, guardrails, logging, rollback, testing, staged rollout, and measuring reduced toil or incident risk. Question 20. How would you conduct a blameless postmortem after a major outage? I create a factual timeline from alerts, changes, logs, and incident notes, then quantify customer and business impact. The discussion should examine system conditions, unclear ownership, process gaps, and missing safeguards rather than individual blame. I separate root causes from contributing factors and identify what would have improved detection, mitigation, or prevention. Each action gets an owner, priority, and deadline. I publish the report broadly and review completion so lessons produce measurable reliability improvements. Focus on a factual timeline, customer impact, contributing conditions, detection and response, why safeguards failed, actionable owners and deadlines, learning culture, and verifying completion. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.